All right, thanks. It's good to be back at one of these things, seeing a lot of familiar faces and some new faces. And I can't tell you how much I hate title slides because there's nothing to say. Sorry my title's so long. Just some standard disclaimers. All of these are preliminary and subject to revision. This doesn't necessarily reflect the views of the Fish and Wildlife Service. There's a report that came out last summer. It's available on the program portal, and all the data that's in it is also available on the program portal. So just going over what the goals and objectives and strategies were for this project. Really just want to try to improve summer survival of silvery minnow by reducing the mortality that's associated with stranding in isolated pools. So there is a bigger, larger, overarching issue, which is recovering silvery minnow, and you can kind of break that into two parts of improving recruitment in the spring and then also improving survival throughout the summer, and just try to break it down into a manageable chunk and just focus on improving that summer survival. Oops. And to do that, I wanted to identify these areas of high abundance. They were also really subject to a high risk of stranding when there's channel drying. And the specific strategy that I used was to use the fish rescue data and see if we could pull out any of the variability in the numbers of fish that are stranded, see if any of that's attributable to the location that you're in the river. And so a couple key perspectives to think about. From Charles Yakulik's integrated population model, if you have about a 10% reduction in the amount of drying, you'll have about a 10% increase in the October CPUE, which makes sense. So what we're trying to do here is kind of see if we can improve on that. Maybe we reduce channel drying by 10%, but we can increase the October CPUE by 15% by delivering flows to areas that actually have more fish. And we want to have about 500,000 is more than our hatcheries can produce right now, and that's just sort of a number to give you some perspective on, if we're talking about only maintaining a few dozen fish in some of these areas, that's not really meaningful. So we want to be talking about thousands or tens of thousands of fish. And this also doesn't address recruitment. They're not going to be spawning throughout the summer. So this is completely disjunct from any spring recruitment, and we're only focused on trying to improve the fish that are in the river, improve their survival through the summer. And I've heard some interesting perspectives that maybe channel drying is good for silvery minnows, and I just want to dispel those right now, that if they get stranded in an isolated pool, it's probably almost certain mortality. We know the pools are shallow, we know that they're small, we know that they only last 3 or 4 days, we know that they're crowded, and we know that they have very poor water quality. So even in the cases that we go and rescue them, the fish are also highly stressed, and sometimes they don't survive. So just a couple pictures so you see, kind of get the idea of what it looks like out there. This is, I think, 2020, and then this was 2018. This is probably about 3 or 4 days after intermittency set in, and you can see that all the large predators have been there dragging the large fish out, and there's just, the water quality in that pool is awful. So I had a couple data sets to play with. There's the riverized data from 2007 to 2022, and then the fish rescue data set from 2009 to 2023. There are other years, but it didn't quite have the information that I needed to run these models. So just a reminder that this model is the average of all of those years. And on the map you can see, this is not all of the places that water could be returned to the river. I just highlighted a few of them. You have the 2 diversion dams, Isleta and the Santa Costia, and the dark blue areas have a lower risk of drying, and the light colored areas have a higher risk. That's already changed because the pump station at the south boundary is no longer there, so what you see on the downstream end there, that's going to start creeping up towards the much higher risk of drying. It's going to dry every year now, so it's no longer in that low category, it's going to be in a high category of drying. So the specific strategies, I looked at the number of fish that came out of an isolated pool and just modeled the average count while accounting for recruitment, which I just used year as a random effect, and then survival. So we see more fish early in spring, and that number just declines throughout the year. For young of year, I censored the data, so early in the year they're so small they actually go through the net, and we don't catch them. And after about July 1st, we pretty reliably catch them in the net. So I just cut off all the data for young of year that occurred prior to July 1st. And like I said, we're estimating the numbers of fish per pool, and it's a negative binomial model, so it's on the log scale. So what you're really looking at is the deviation from the average. So if you have a year where you're averaging 10 fish per pool, you're talking about, are there twice as many fish in these pools, or are there half as many fish in these pools? It's not the actual number that shows up. You can estimate that, but this is really just talking about relative to the average, how many more or fewer fish are there. And after doing that, I want to know, was any of the leftover variance, could you attribute that to where you are in the river? And we used a random effect for that. Some of the years have a lot, some segments have lots of data, other segments don't have a lot of data. So we threw it all in as a random effect to take advantage of the partial pooling. Now the report that I circulated, I had two different spatial scales. I looked at a 400-meter segment and a 2.5-kilometer segment. The 400-meter segment is not that interesting because there's not that many fish that show up in any given 400 meters. There could be a lot, or there could be not very many. When you start moving it out to a 2.5-kilometer segment, you get a little more consistency. And the other change from the report is I had 5 categories. Here I've broken it down, there's just 3. There's just really cold spots, which are the brown areas, and the really hot spots, which are the green areas, and then everything else gets into the average, which is the white. And that is, the cold spots have fewer than half as many fish, and the hot spots, the green areas, have more than twice as many. So if you had a year where you're expecting to see 10 fish per pool on average, those brown areas would have 5 or fewer, and the green areas would have 20 or more fish per pool on average. Again, there's still a lot of, the data it's really zero inflated, so you could go to a pool that's in a hot spot, you could still have an average of 20 fish for that whole segment, but lots of pools are gonna have zeros. And then you'll hit a pool that has 400 in it. And it ends up that there's about 10 segments of hotspots for adults and 11 for young of year. And where the report kind of left off, I'm picking up now. Really want to know, do these hotspots actually have more fish in them? Is this like something that's useful? So I started just by calculating, well, how many fish on average were in those pools in those 3 different bins, and then rank them over time to see how well the model performed. And just when you do this, you have to remember that there's 3.5 times as many average areas as there are hotspots. So even though the hotspots might have more fish per pool, there's just a lot less area of that. So there may still end up being more fish in the average areas just because there's so much more area. And so this is that relative ranking. So brown is the cold spots and the green is the hot spots. It actually works not very well for young of year. It does work pretty well for adults. That period from 2016 to 2020 is just kind of all over the place for young of year. I guess the one year that is kind of interesting is 2019, when it's reversed for both young of year and adults, where the most fish came from the cold spots and the fewest fish came from the hot spots, which you can get to this figure and kind of explain that a little bit. So this is really kind of the meat of the presentation. On the y-axis, you have, this is the sum of all of those hotspots. So there's 25 kilometers of hotspots for adults, 27.5 kilometers of hotspots for young of year. This is the sum of all of those fish in all of those hotspots by year, and the proportion of total fish that we collected during rescue. So in some years, there's a really, really high proportion of fish that show up in the hotspots, like 2012. Almost 100% of all the silvery minnows we collected showed up in those hotspots. But it also shows the number that was each year based on the size of the dot. So in 2012, even though pretty much all of them showed up in the hotspots, there was less than 100 of them. So there was just not much that you could have done because there were so few fish. Even though they did show up in the areas where you thought they would, there just weren't very many of them. Start looking at like that series from 2017 through 2018. 2017, you have a huge influx of young of year. It was a great water year. Almost all of them showed up, like 75% of them showed up in the hotspots. That's what you would like to see, but then these fish transitioned to adults in 2018, and all of a sudden now only like 10% of them are in the hotspots. That's because there was very little drying in 2017 and very extensive drying in 2018. So in 2017, we only looked in the hot spots, so that's where the fish showed up. In 2018, you have a much larger snapshot of the river, and there were so many fish, they're just spread up and down the river in 2018. So in a year like that, you could have actually just picked anywhere and increased flows, and you would have affected a large number of fish because they were just so dispersed in that year. And then you go to 2019, and it looks like there were no fish anywhere. And that's because even though 2019 was a very high flow year, there were a lot of young of year in the river, there was very little drying that occurred, and it only dried in the cold spots. So I think we sampled 126 pools, and only 11 of those pools showed up in the hot spots. So what's not captured on this is how much drying there was in any specific year. So the most interesting year is probably 2023 because we had high flows, we had a lot of recruitment, there was a lot of fish, there were like 4,000 young of year. But there's still fairly extensive drying. And what you see is on the young of year, about 55% of the fish showed up in those hot spots. In the entire data set, there's about 120 kilometers, and that doesn't all dry every single year. It's subsets. There's about 21 to 23% of that 120 kilometers is considered hot spots by the model. And in 2023, we did fish rescue on 27 kilometers. 7 kilometers of that was considered hotspot. So about 25% of what we rescued was a hotspot, but 55% of the fish came from those 7 kilometers. So there are hotspots, and sometimes there are more fish in them, that's the good news. There are hotspots out there. There are areas that over the entire data set of 12 years or whatever it was, there are areas where there are more fish. But it's still really widely dispersed. You look at 2018 and there were just fish up and down the entire river. So it's just, even though there is good news, you have to temper it a little bit by remembering that it's gonna be really hard to conserve a lot of the fish if you're only talking about small amounts of water. And the other kind of bad news is if you go back to the maps and look at those, the hot spots for the adults and the young of year didn't necessarily overlap. So you do have to think about which life stage you're trying to benefit by delivering water. And then it wasn't part of this presentation, but connectivity is important. So having 10 kilometers continuous would be better than having 10 1-kilometer sections, but also 10 1-kilometer sections is better than 0. So the kind of the next steps, this really is looking forward to an adaptive management approach where we want to balance the amount of water that's available and where it can be delivered and when it can be delivered, and think about how many fish are in the river, what life stage is already in the river. Are you trying to keep young of year alive? Are you trying to keep adults alive? And just kind of remember that there's some years where we might have gone through 2 or 3 years of just really terrible recruitment, and there aren't hardly any fish in the river. And as counterintuitive as it sounds, it may be better to just save that water for something else. Probably the best example is that south boundary pump. We did the flow reduction experiment in 2020, and when we went through there and did the fish rescue, we only caught, I think, 63 adults. So that's a 20-kilometer section that was very expensive to maintain flows through, and there were only 60 adults in there, which I think if you went forward in time to the next spring, that's probably less than 10 fish that would have survived to spawning. And that's, when we do the augmentation, we're talking about hundreds of thousands of fish that we put in there. So in that case, that was probably not a great use of money to support those fish. And the real question is, can we actually reduce stranding enough that it matters? Can we make these refuge areas large enough that it actually does improve persistence? So there's been a lot of discussion on what is the value of fish rescue, because it's just really not as effective as we would hope it to be for management, just because the fish are in such bad condition by the time that we get to them. They usually don't live through it. It is useful in a subset of years. There was the 2018 when we had early drying, there were lots and lots of fish. I think we moved around 90,000 minnows. Early in the year, the water was cool, they were still in good condition. We probably had much higher survival than some years when we were out there rescuing in July. So there is still a little bit of use. But where it's really been useful is it's generated so much data. And it's been useful for exploring some of these options, including this presentation here. And over the years, I don't have a slide, but there's like 9 or 10 peer-reviewed articles that have come out of this. So it has been useful, even if it hasn't quite given us what we were hoping it would. So where I kind of see it going is just transitioning to a monitoring protocol where we can still maintain that capacity to do fish rescue when we need to, not totally give up losing all of the data, but really, really reduce the workload and the cost associated with it. So I just want to thank Eric. You know, a lot of this was spurred by conversations with Casey Ish and Paul Tashjian trying to think about this, and maybe I didn't quite get the answer that you were hoping for, but I think it's like there's still value in this. I stuck with it and have found this, and I think there's more, and I'm looking forward to working with Charles and really getting the last step of this out there. So that's all. Any questions?
Thank you. We have a few minutes for questions. Are there any questions? Yes.
Yeah.
Oh, so we'll give you a mic.
I heard you say you were moving, like, in 2018, you just said you moved like 90,000 fish. You're obviously moving them upstream to where the water still is. Is there a carrying capacity? Like, how many minnows can survive in a given area of water where you're just putting them in to compete with the other fish?
Yeah, there probably is. I mean, I don't know what the answer is, but when in that year, that early, there was still pretty decent flow, but I would think, we have another project, and we're looking at like 10 to 15 CFS this last summer. And I mean, there were just thousands of fish. It's not just minnows, like they're competing with everything. So yeah, I think there really is. I don't know what the answer is. Nowhere's really ready to receive 100,000 fish, and no facilities are ready to receive that number of fish. So yeah, I think that probably is a concern.
Thank you. Any more questions? Yeah, in the back.
Hey, Thomas, great talk. So I was just curious, your latest thoughts on the concept of reducing the rate of river drying. So when you get to that point, what sort of insights have you had over the last few years in terms of, is it worthwhile? You kind of mentioned the idea of, how much water to spend. And do you see some maybe positive impacts with reducing that rate, or is there some sort of threshold where it's just happening so quickly that it doesn't make a difference?
Yeah, I have like a two-part answer for that one. Like to benefit the fish, like are you talking about like the fish will self-rescue? They'll rescue themselves and just get out? Yeah, I think there probably is a rate, but it is so low that it's not reasonable. It's like hundreds of meters a day, 100 meters a day. So low that it's not really reasonable. I was hoping it had been accepted by now. Like when we did that pumping study, we have some of that, and it kind of shows that fish are able to find nearby refuge because their population is not decreasing as quickly as habitat is lost until you see intermittency form. So they are moving short distances to stay in water, but they're not moving long distances to stay in water. And it's just because the flow reduction is so rapid. But there is the data side of it that it would be, if there's about more than say 6 or 7 kilometers that dries in one day, we're not going to be able to cover all of that with the staff that we have. So last couple of years, we don't have a lot of data from below the South Boundary Pump Station because it's dried 20 to 30 kilometers overnight, and we chose to use this analysis and go to the areas where we think there are going to be more fish anyway. And so some of this is a little bit tenuous just because we don't have a lot of data from some of those areas. So if that was an important thing, then yeah, managing drying is important for collecting that data.
Great. Oh, let me just check the time real quick, Paul. Real quick.
Thank you, Thomas. Great stuff. Appreciate you looking into this. So do your findings then support the idea of when things are thin to target the hotspot areas in terms of places, if we're going to look for places to target where we bring least water back to the river? Is this what you're suggesting?
Yes.
Okay.
there are fish to be supported. So it depends on like how many fish were there before drying occurred. If there's a significant number of fish, then yes, there is value. The model's going to be wrong sometimes, but over the averages, those are the better spots. But
Okay.
but like I said, if you've gone through 2 poor recruitment years in a row, there's just not a lot of fish out there, period. So it's probably not worth doing any of that.
That's interesting. We should talk more about that, how we could actually,
I mean, this is what I'm really relying on Charles for. So
Yeah.
there'll be a more
Yeah.
like another sort of an integrated population model. So.
yeah, great. Well, thanks, Thomas. Yep.